Alright, as you can see, we are on to Module 4, Lesson 5. When you come in the morning, you're going to be given a sheet that has a white circle on it and a red circle on it. You're going to be asked to cut them out so that they are a circle with a black line where you actually cut just the mid of the black line. Same thing with the white circle. So we're using a circular protractor to understand a 1 degree angle as well as a 1 out of 360 of a turn. We're going to explore benchmark angles and we're going to use our protractor. So what we're going to look at first is actually what you need to do with your protractor. So here are our two pieces. Hopefully you can see them. Okay, if we take our white circle first, I have cut on the black line. We want to see how many right angles are actually in this circle. So if I put my right angle template in, that's 1, and it's right on this straight line. If I now put it here, that's 2, and that's straight down. If I put it straight across, that's 3, and then if I put it straight up, that's 4. So there are 4 90-degree angles, which tells us we have 360 degrees in this circle. Next, you're going to take your 2 red circles you cut out this morning. You're going to put them one on top of the other with the open black slit lined right up. What you are now going to do is you're going to hold on to the white circle at the bottom so that you can allow the top red circle to sneak underneath. See how we have this piece getting bigger? So you want to have your white circle held just a little bit. See, I have it showing just a little bit. And my red circle is going to slide underneath that slit, just like that. As we move, right now we have a 360-degree angle. But as we move, what do we notice about the white versus the red? The white is getting bigger and the red is getting smaller. Let's pretend that the white is the angle that we're dealing with. Can we agree that this white is an acute angle? Yeah, we can. Let's keep going. Can we agree that that is a right angle? Well, we can always check it with our template. Looks pretty right to me. You guys remember, what kind of an angle is that? Yeah, it's obtuse because it's bigger than a right triangle. See how my right triangle comes down and across? I have all this left, therefore it's obtuse. It's an obtuse angle. If I go a little bit further, I have just made a straight angle, which is a 180-degree angle. So I can say that half of my circle is now highlighted, or is now white, because the white is what we're looking at as far as the angle. So 1/2 of it is white. If I came back to that right angle, I could say that 1/4 is white, because we knew there are 4 right angles. So 1/4, then we have 1/2. Let's see what happens when we go again. How much is white now? If you said 3/4, you are correct. And then, let's try this one. Oops. How much is now? 360 degrees, or it's 4/4 is white. Alright, so that was us moving in quarters or 1/4 pieces. Let's go ahead now and move into eighths. Who thinks eighths are going to be smaller than fourths? Well, let's find out. This was a 1/4. This is an 1/8. How many eighths are going to take to get a 1/4? If you said 2, you are correct. How many eighths to get to a 1/2? Let's see, if this is 1, 2, 3, and 4. 4/8 is the same as 2/4 or a half. This is 5/8. That is 6/8. So 3/4 is the same as 6/8. You see the connection between 3 and 6 and 4 and 8? They are each halves, you're right. Then of course we have, oops, wrong way. And of course we have 7/8, and then we have 8/8, which is our whole. Imagine if I wanted to figure out how many hundredths are in here. Well, let's see, if that's 1/100th, how many hundredths will it take me to get around? It took me 4/4, took me 8/8. How many hundredths? Yeah, 100 hundredths. It would be 1, 2, 3, 4. They'd be really, really small, right? So let's think. We said there are 360 degrees in this circle, right? So if there are 360 degrees and this is 1/360th, how many times, or how many pieces will be in this circle or this angle? Yeah, there'll be 360. 1, 2, 3, 4, 5. Do you want to sit here and listen to me? Absolutely not. But whatever your degree is, that's how many little angles are in there. So there are 361 degree angles in here. Here is actually something called a protractor. And this protractor has been broken up into degrees already. It is at 0, and it works its way around. 0, 90, 180, 270, 360 is the same as 0 because it's all the way around, so it's at the same spot. 0 means no degrees have moved. 360 means all of them have. And you can use your right angle template to see that this is indeed a right angle. And then we see there are 4 right angles. And 4 times 90 is 360. We're actually going to use our protractor again. And this time we're going to actually make some benchmark angles. I know what 90 degrees is because I can use my right angle template. But I want to benchmark 45 degrees. So I'm just going to kind of cut it in half. I'm going to draw a straight line along my base here and label this 45 degrees. And then I'm going to move again to my right angle. And I'm going to measure this as another 45 degrees. And degrees is this little tiny O. But is that really, so those two 45s together equal 90 degrees. So let's go ahead and do another one. And so if I add another 45 on, 45 plus 45 is 90, plus another 45 is going to be 135 degrees. So I'm going to make this 135 degrees. And then again, if I measure it all the way around, another 45, it will be a straight angle, which gives me another 45, which tells me I have 180 degrees. Again, another 45, about. I'm going to have 225 degrees. And then if we continue on, wrong way. We now have 270 degrees. If we continue on, now this is obviously not going to be perfect, so I don't want you to stress over it, but try your very best. So if I take 270 and I add 45 degrees to it, what do I get? You're right, I get 315 degrees. And then of course my last spin gives me 365 degrees all the way around. Now their central point should kind of be here in the middle. It's pretty close. But now we have some benchmarks. We're going to do the same thing with the other side during class. The last thing I wanted to show you was using the protractor to show 360 degrees. Imagine that I have a line straight up at my 90, straight over at my 0. Just like this is right here. You can tell that that's a 90-degree angle, but if you're not sure, you can use your right angle template, and it is 90 degrees. So this right here is 90 degrees. And actually, I shouldn't make it a circle, should I? I should make it a square because I know it's 90 degrees. Which makes it a right triangle. So let's imagine that I make some other lines. Let's imagine that my next line goes off at an angle. It's landing on 120. I'll tell you that this angle is 120 degrees. But if we look at the arc, is that more than a right angle or less? Well, of course it's more, which makes it an obtuse angle. Obtuse angle. All right, let's try another. Let's get rid of that line. Ooh, now we have our line coming in. Look at that angle. If we make our arc here, is that more or less than a right angle? Well, you can always test it, right? Here's my right angle. Holy cow, I totally covered up this other line, which means this is an acute angle. All right, and let's just try one more. This one is falling between the 40 and the 50. So what kind of an angle do you think that would be? Well, it would be a 45-degree angle, you're right. And it would be acute, correct. All right, last one. This one's kind of tricky. This one arcs all the way around. So even though it looks teeny tiny, you have to look at your arc. And your arc shows you that it is much larger than just a 90-degree angle. Therefore, it is obviously obtuse. It is much larger. And if you look at where the line falls, it actually falls on 290. So it's 290 degrees. All right, guys, that is protractor use. We will see you soon.